It's time for our last speaker. So he is a man of many talents and interests. Among them are craft beer, cool pubs, and digital comedy. As he says, he's also an occasional JavaScript developer. He joins both passions, beer and technology, in the famous PubConf events. Please welcome the famous Todd Gardner.
Hello, everyone. How's it going today? Fine, good, wonderful, great. All right. So welcome, everybody. My name is Todd Gardner from Track.js, and I have the great pleasure of introducing our next speaker, Mr. Harrison, the VP of Information at a company called InGen. InGen is the company behind tons of great theme park adventures like Jurassic Park. And Mr. Harrison's going to come on stage here in a minute, and he's going to share some lessons learned during the first park. So many things that they did right and that they did wrong so that we can all learn from their knowledge. If you're not familiar with who Mr. Harrison is, here's how he fit into the overall Jurassic Park leadership. At the top was John Hammond, who you might recognize, along with his general counsel. Mr. Harrison was a direct report working alongside Robert Muldoon and Ray Arnold. Dennis, who you might remember, reported up through Mr. Harrison. So without further ado, please welcome Mr. Harrison. Hello, everyone. I'm pleased to be here today with you. Let me be the first to say, welcome to Jurassic Park. You may or may not have seen the documentary made about our work. It received some notoriety, and it focused overly on our issues. It over-dramatized some events. Our first attempt had some unfortunate consequences, but only 4 people died, and I think we learned a lot from our experience. This talk is going to be an uncomfortably close look at the successes and failures of Jurassic Park. We put together this retrospective to share our learnings with the larger community here, as well as we move into our brave new world. But more on that later. One of our core problems, which we're going to talk about more today, was perfectly articulated by one of our consultants, Dr. Ian Malcolm. And I think he was specifically speaking about our choices of software and automation systems. We were so preoccupied with whether we could, we didn't stop to think if we should. And so that brings us to build versus buy. Should we build something? Should we create some piece of software or information system? Or should we buy it? When should we do each of these? So let's first talk about build. Jurassic Park built a lot of custom software, a lot of custom systems to do the things that we did. Why would we do that? When you build a piece of software, it is by definition unique. It's solving a particular problem in your particular way that nothing else will do exactly the same. It solves your problem within your own context of technology and people, and it conforms to your tolerances, your organization's tolerance for risk. How is it going to break, and whether or not you're willing to mitigate how it's going to fail. No one is going to solve a problem quite as perfectly as we solve it for ourselves. But probably more important is that building software is just fun. It's exciting. Developers want to code. They want to solve new problems. Building new things allows us to try new ideas and escape the normal tedium of working on the legacy system and pulling the next ticket. Building improves team morale, and it harnesses the passion of your people. Jurassic Park was able to hire our own ace developer, Dennis, largely by tapping into his passion, which was strangely building security, surveillance, and locking systems. He was fascinated with their behavior and really wanted to build his own piece of security. And Jurassic Park gave him the opportunity to do it. But beyond solving a basic problem, as soon as you start getting into actually building a piece of software, you have to dig into all the details. Getting beyond the core problem that you're trying to solve, you have to handle edge cases, failure modes, bad user input, service delays, backup and security. All of these edge cases is where the real costs of building our own piece of software lie. And the majority of work it's going to involve in operationalizing code to solve our problems. It's a common anachronism at Jurassic Park to be 80% done when we'd solved the core problem, but there was often 200% more work left to get it actually out the door. And no example is more true of this than in our door locks. At Jurassic Park, we were doing IoT before it was cool. We had internet-connected door locks. Unfortunately, we failed to think of failure modes like, how do we lock the door if the power is out? Clearly, there should have been a physical handle for us to be able to still lock a door even if our system was online. But that had unfortunate consequences. Part of building a piece of software is going to be in maintenance time. Bugs, patches, security integrations, debugging why the headlights are running on car batteries. 1,000 annoying little tasks that are going to happen months, years after you initially built your system. This is where the true cost of successful and valuable software lies and can be as much as 90% of a total project cost. All of these annoying little tasks that are going to happen to a system months and months after it's built. You can build something interesting in 3 months, but you'll have to maintain it for 10 years. When we build software, we're also responsible for maintaining its health. How do we know if it's running well? How do we know if it's still fulfilling the purpose it was created for? We'll have to spend time not only building it, but building in the observability, telemetry, and monitoring to make sure that it works, and to make sure that we know when it's not working. And this is going to take way longer than we think to get it right, because we need to know when it goes down, but we don't need to know everything. You need to get paged at 2 a.m. when something is down, but not paged at 2 a.m. every night and you start ignoring it. This is going to take a lot of failure and iteration as you learn about your system and how to do it right. Of course, maintenance time is only going to come due when you've forgotten how the whole thing works. You'll have moved on to bigger and better things with your job, and remembering how to clear out caches, recycle the services, do a deployment, upgrade the underlying infrastructure might not be top of mind anymore. So you'll have to depend on the documentation that you've left for yourself or for other members of your team, which frankly probably sucks, it's probably incomplete, and it's simply incorrect. So you'll spend even more time to do the maintenance than you expect to because your documentation's probably not going to be correct. And of course, that outage is all going to come together when there's other stressors of the maintenance time, like your VP shoulder surfing over you asking, is it fixed yet? Is it fixed yet? Is it fixed yet? Outages are part of this maintenance time. And as we all know, things don't always go as planned, right? Sometimes systems go down. Sometimes electrified fences go offline. Handling the recovery is part of our cost. Do we know how to restart our systems? Can we get across the compound to flip the breaker before other bad things happen to us? Are our backups good and current? If we don't know these things, handling an outage can be a much bigger problem than we think it is. Now, there's a common term for this of bus factor, of how many people in your organization would need to be hit by a bus for you to be in trouble, for you not to know how to recover your systems or know how something works. Now, we didn't have buses on Jurassic Park, but we did have Dilophosaurus, and so we called it the Dilophosaurus factor. How many of our engineers would need to be eaten by a Dilophosaurus for us to be in trouble? And unfortunately, the answer to that was one. One engineer had to be eaten by a Dilophosaurus. And then we didn't know how large parts of our infrastructure worked anymore. Having a low Dilophosaurus factor creates tons of sustainability issues. How are your teammates going to help out when you're unavailable? This can happen for a lot of reasons, not just being eaten by a Dilophosaurus. But large organizations tend to create fiefdoms of knowledge, where this team is the only one who knows how to do the deployment, and this team is the one who knows where the data is, and this team knows where the web layer is, or this team knows how the JavaScript works. And these fiefdoms, create these boundaries for you understanding and makes your Dilophosaurus factor even harder to understand. If there's one engineer who knows how all your JavaScript works and they get eaten by a Dilophosaurus, you're probably not updating your UI anytime soon. So how do you actually understand whether you should build a piece of software? And so when Dennis first came to us and asked, hey, I want to build that security software, we ran some numbers to figure out, does it make sense? We found this calculator online from a company called Baremetrics, and it allows us to plug in some data and understand whether or not something is going to be financially worthwhile for us. And so Dennis and I were going to work on this security system together with an average employee salary of $120,000 at the time. We thought we could build it in 2 weeks and spend 1 day a month on average doing the maintenance that we thought was going to be required. We also looked at buying, like an alternative, what could we license something for, and we found something competitive for about $3,000 a year in licensing costs. Well, what the calculator did for us is it let us see that those numbers, which didn't seem so bad going in, was actually financially terrible for our organization. That 2 people at $120,000 salary was going to cost us $9,000 to build it. But what really kills us is that 1 day a month to maintain it ends up costing $7,800 every year. Every year. And so we're losing the privilege that we have of building this piece of software, which wasn't that big of an investment, turns out to be losing our organization $4,800 every year versus building it, or versus buying it. But almost more important than these fixed costs of what it takes to build a piece of software is what you could have been doing with your time. Each of our companies has something amazing at its heart. Jurassic Park made dinosaurs, something that we did better than anybody else. Why were we spending our time building a piece of security software when we could have been building dinosaurs? That's opportunity costs. It's what you could have been doing in your organization, what you could have been focusing on to make your organization, your company, your Jurassic Park awesome, rather than building a mundane back office piece of software. And so if we look at all of the different costs involved in building software, we have the creation time. How many days, how many engineers is it going to take to build the thing, which is probably going to be more than we think it is to handle all of the edge cases. We have all the maintenance time that's going to go into it, handling outages, patching, security, all of those sort of things, and the opportunity cost, what you could have done with your time rather than focusing on that. A lot of the time, especially for you folks here, it's worth the cost. You need to build something. But we can't build everything. Code is as much a liability as it is an asset to our organization. And so we can only handle so much. Our organizations can only handle so much custom code. At Jurassic Park, we had all the major problems of a theme park and a major zoo, and the computers were never quite on their feet. You have to be aware of what your organizational maturity is. And the maturity at Jurassic Park was quite low. We didn't know what we were doing. We were just kind of like throwing code at the wall and seeing what stuck. To be successful with a lot of custom software, you're going to need ownership policies, product managers, planning horizons, change control, all kinds of, boring meetings that you have to sit in. It's not always fun, especially for engineers. We just want to sling code. But to succeed at building everything that our organizations need, you need a high level of maturity at that things. So do you have that? Does your organization have the required level of maturity to build a lot of custom software? And even if you say yes, Yes, we have that, or yes, we can get it. Do you even want it? Do you want your company to have those controls in place to manage a lot of diverse pieces of custom software? Because frankly, maturity is overrated. We don't want to do those things. We want to focus on a handful of really great pieces of software that make our organizations thrive and grow. We don't want to build everything. We don't want to have to plan dozens and dozens of different products, and when can we update our session management API to make sure all of our other services don't break? It's boring, we don't want to do it. So now let's talk about buying software. We also bought a lot of software at Jurassic Park. But what does buy mean? The build versus buy kind of notation is kind of old-fashioned. It's kind of from a heyday where you bought software from SAP and Oracle and Microsoft, and it came in giant boxes with expensive consultants. We don't really do that anymore. What about things like GitHub and pulling down packages and building on top of other people's code? I think a lot of the same concerns with whether or not you should build something or use somebody else's code still applies. But maybe we should call this build versus use instead of build versus buy. Sometimes we might pay a licensing cost to use somebody else's software. Other times it might be open source. But I think we should think about the same things as we're going through it. So why would we build, or why would we buy or use somebody else's software? First, buying software is fast. You have a problem, you find somebody who solved it, you download it, done. Problem solved, on to the next thing. It would have taken Jurassic Park a long time to design and build our own vehicles. So we didn't. We bought vehicles from another provider. Buying them and then adapting them to our purposes was faster than trying to figure out all of the things that would have been required to build our own automation facilities. All we had to do was, add night vision and poison-resistant windows and a T-Rex strength roll cage, and we were good to go. But frankly, it never works out quite the way you need it to. Buying can suck. Using other people's software never works quite as good as you think it's going to. It's always a little rough around the edges. The API is not quite what you think it should be. Maybe that installation isn't quite as smooth as you think it is. It doesn't behave the way you want it to, and when something goes wrong, there's little you can do when the T-Rex-proof sunroof breaks, except call Tier 1 support. Software installation for large pieces of software is a complex thing. We installed a couple of big pieces of software at Jurassic Park. This one in particular was a 3-year project. We spent 3 years figuring out how to install this piece of software. And it required 24 outside consultants to help. We had buy-in all through our organization, from the CEO, John Hammond, all the way down. It involved hundreds of planning, design, coordination, and implementation meetings. The kind of meetings that just eat up your whole day. Your calendar is bricked from 8 a.m. to 5 p.m. We even had a project manager with a shotgun ready to get involved in case anything was to go wrong. But despite all of the preparation, when it comes time to deploy a complex system, it often comes down to luck. As Ray Arnold once said before deploying new software in our infrastructure, hold on to your butts. Despite all of that, over half of software implementation projects fail, according to a recent study. Ours did, despite an impressive level of planning and preparation. So buying somebody else's software isn't a surefire plan for success either. If you're going to buy some software, eventually you're going to be working with vendors. Sales presentations, box lunches, trying to convince you that they have the solution to all of your problem, which of course they don't. They'll probably sell you on one of two options on why their piece of software is the best and you should pick it. And the first option is that it's industry standard software. At Jurassic Park, we had some complex engineering efforts. One of them we called Design to Hatch. It was all of the work that went in from designing a new dinosaur genome into hatching. And in some cases in that software, or in that flow, we needed, boring, standard things that a lot of other industries needed, like egg management. It's not all that different to manage a dinosaur egg than a chicken egg. So we were able to buy a piece of software with our robotic management system that was good enough. It was industry standard. Here's how you manage eggs at scale. And that software assumed a given flow of work. Here's how you do this business process. And by just saying, yes, we're going to change our process to do exactly what that software says, everything was great. We saved a lot of heartache by just changing what we did as an organization to fit into what that software wanted to do. A great example of this is onboarding new employees. You buy a piece of software that's industry standard, then when you bring in an employee, they probably already used that piece of software and they're ready to get started on it from day one. The second option that a vendor might pitch you is that their software is highly configurable to your needs. So at Jurassic Park, other parts of our process was really unique and superior to what we thought a company should be doing. And we needed software that could adapt to the needs of our business, to really to really key in on what we were trying to do as a business. Now, that's all still under NDA, and I can't really talk to you about it, but we're all engineers in this room, so I imagine many of you are familiar with a product called Jira. Yes? Jira is what I would call highly configurable, and that's how they would sell it. Here is a tool that you can configure to your business process. You've probably figured out how you want to run work in your software development company. And so you can take Jira and adapt it to how you want to run work, which is great if you're really doing things in a superior way. But if you're not, being a highly configurable piece of software is just going to take your terrible process and make your terrible process go bad faster. And so you have to have some caution when you adapt a configurable piece of software to your organization. Now, regardless of which path you choose, you need to be aware of vendor lock-in. Now, as you're using pieces of software from a vendor, the more you customize it, the more you tailor it, the more you make it specific for your organization, the more you lock yourself into using that vendor, the more you're creating walls around yourself that you have to continue using that vendor for a long period of time. And this is something that vendors know about. This is something that vendors are doing explicitly. It's called making their product sticky. The more they can do to make their product something that locks you in is called being sticky. Now, at Jurassic Park, we had a CRM. And we used a product called Salesforce at the time for our CRM. Is anybody familiar with Salesforce? Some? Yeah. All right. So Salesforce allowed you to customize. It was definitely a configurable kind of approach in how they tried to sell it. You could configure the Salesforce CRM platform to be tailored to your needs, how you wanted to sell. And we were trying to do some new things. We were this weird crossover between a zoo and a park and a destination and all kinds of things. And so our sales process was a little unique. But in order to do that in the Salesforce platform, it involved writing code that's not in any language. It's their language. They invented it. And querying their data, not in any way that would work anywhere else. They invented their own SQL-like language. And so every line of code, every developer hour that you put into customizing Salesforce was a brick in the wall keeping you from ever leaving Salesforce. And so this is a general problem with a lot of different pieces of software where you're building things in their tool that are proprietary to their platform. And what you need to be aware of is that those things are going to be a strong reason for you to never leave that platform. Because buying, installing, and integrating software often sucks, at Jurassic Park we had a tendency to overbuild things. We built our own monitoring system, we built our own tour operations, our own telephones, our own video surveillance, our own door locks. We had what I would call not invented here syndrome. If we weren't involved in building it or highly customizing it, we didn't want it. We thought we were better at it. We didn't want to use Twitter, we'll build our own Twitter. We didn't want to use Dropbox, we'll build our own Dropbox. It was never as good as Twitter, and it was never as good as Dropbox. But in some cases, we did buy into pieces of software. One example is this hot startup that we found called Raptor. Their line was securing the unsecurable. It was this hot tech startup featured in all kinds of tech press. The community was buzzing about them. They thought they could secure any of your assets, anything that was just so dangerous, so volatile, you could lock it in with their piece of IoT-driven security software. And so we implemented it because we had some volatile assets. The company was all pumped up by venture capitalists that were backing them, but like many Silicon Valley startups, it wasn't underlyingly profitable. It didn't make enough money to cover itself, and it wasn't sustainable. A lot of great software out there is unsustainable early on. But the trouble is that if you're working with a piece of software that's at that unsustainability phase, if something goes wrong, that whole company can just disappear one day. And unfortunately, that's what happened to Raptor. Raptor had been built on Node, and like many projects, it had downstream dependencies, like leftpad. Leftpad was this trivial piece of software that padded out a string on the left, I think. If you hadn't heard this story, this was a piece of software that was just a trivial, like 2 lines of JavaScript code in NPM, but thousands and thousands of projects took a dependency on this. And so they were all using somebody else's software, and they thought it was a more valuable thing to do. So when the leftpad project disappeared, much of the Raptor infrastructure failed catastrophically. Many of their customers were impacted, including Jurassic Park. And so because of this huge liability of all of these secure assets failing all of a sudden, Raptor crashed and was basically sold off to Oracle for like $1 and its employees. And so it just disappeared one day when we needed it the most. So when we're using a piece of software that somebody else wrote, that another organization is responsible for, we have to think about, is that organization profitable? Are they reputable? If we need them in 2 years, are they still going to be around? Are they going to have disappeared? And I think that's an important thing to think about on both the build and the buy side, is the thing that we're doing sustainable? So I've told some stories about things we built, and I've told some stories about the things we bought. And so how do we decide between them? As we move forward, how do we think about this? In the last Jurassic Park, we had some well-deserved mud on our face. We failed. I failed. 4 people are dead. Our lawyer is dead. Our project manager's dead. Mr. Arnold is dead. And Dennis is dead. But how can we do better? What can we learn from this? I think I got a bit too far away from the technology in my VP role, and I didn't ask the right questions to keep the engineering team on track. Questions like, what's the impact of failure? Let's say, hypothetically, everything goes wrong. I know it'll probably never happen, but let's say everything goes wrong. What's the impact of failure in this case? Do people die? Does the business lose money? Or is an engineer inconvenienced? So don't get sucked into analysis paralysis trying to figure out the perfect decision if it doesn't matter. Let's not sweat the small stuff. Second, when we're trying to solve a problem, do we need competitive advantage or competitive parity? And these are MBA words that we heard a lot from our consultants. So maybe a better way of phrasing this, which I heard from one of our other consultants, Dylan Beatty, that if you couldn't sell it, buy it. And I think what he's trying to get at is that if you're not building something, if you're not solving a problem that's so important and valuable and unique that you could hypothetically take your software and sell it or contribute it, that somebody else would find value in it, then maybe this isn't worth your time. Maybe this isn't worth your time and energy and money to invest in building that piece of software. And so in the new kind of open source world, I would say if you couldn't contribute it, if your solution wasn't novel enough that you could build a new open source package that other people would use and find valuable, then maybe you should just buy a solution from somebody else. Third, what is our bias? Here's a photo of us mob programming some of Dennis's systems after he left. while we reviewed his code, we noticed a bias in his choices, a bias to build everything. There were no third-party callouts. There was no services he would call out to do anything. It was 2 million lines of wound-together C code to solve every single thing that he ran into. And so we clearly had a bias to build, that we weren't thinking about it. We weren't actively making the decisions. We just had a culture that we were going to build everything. And I think we need to step back from that and think critically about what should we build in our organization and what are we not good at? What should we buy or leverage from somebody else? Fourth, what could we do instead? If we didn't build this thing, what could we spend our time doing? If we didn't spend that time building a security system, could we have built a bigger, scarier dinosaur? I think we could. And I think the answer would be clear if it came down to those choices. Who would want a better security system when we could have a bigger, scarier dinosaur? I think that's what we should do. And 5, is it sustainable? Regardless of which path we want to choose, whether we're going to build something or use it from somebody else, we have to think about, is this sustainable, what we're doing? If we're going to build something, do we have the capacity and maturity in our organization to manage another piece of custom software? Can we do it? Like, as this going to work in with everything else that we do, can we manage this piece of software? Are we willing to commit to the maintenance capacity outages necessary to really do a good job building a new piece of software? Or if we're going to buy it or use it, who's making this? What's the team behind this software? Is it one poor developer in her basement that's not getting paid and is doing it in her spare time? One day she's going to rage quit and just disappear and delete the package off of NPM. Like, you can't depend your organization on an organization that is not sustainable. And so know that, think about that. When you're going to depend on something, know something about the organizations behind it so you can make sure that they're going to be there for you when you need them. So we're thinking about next time, the next Jurassic Park. Next time, we're going to do this right. This is going to be good. One of the problems that we had with the last park was that it was too remote. It was way off in an island in the middle of nowhere, too isolated. We couldn't respond fast enough to the issues we had. And so I'm pleased to share that we're finalizing plans to build our next park right nearby in Stanislava Park, here in Wrocław. We're actively hiring, especially in the Raptor Operations Division. So please come by and see me afterwards for an application. Last time, the system that we built, all that C code tied up together, it just wasn't very flexible. And so next time we're going to build this in JavaScript. We're going to build this in modular JavaScript so that we can actively make smaller decisions about what modules we're going to build ourselves because we think it's unique to us, and what stuff we're going to call out into third-party services or pull something down from GitHub to accomplish it. We've hired some new developers. This one, Newman, is fresh out of a code school after leaving the US Post Office. He's got some exciting ideas about distributed systems that we're going to try. And we're putting in practice our ideas about build versus buy. So the new Jurassic Park is going to be built on JavaScript. And so here's a debate that we're running right now in our organization and how we're thinking about it. So because the new Jurassic Park is on JavaScript, like most JavaScript apps, it's going to break unexpectedly from time to time. And so we need to look at better ways to monitor and understand how our system is going to work. And so we first thought, we're going to build this. We know about our JavaScript. We should know about how it fails. How are we going to understand that? And so if we were to build this, first we're going to need to write like an agent, something to collect data from our system. But we know JavaScript. We can do that. And then we're going to need to put it somewhere. We're going to need some sort of data structure somewhere to save that. And we're going to need a dashboard of show us the data about how our systems are performing. We're going to need anomaly detection and alerting so that we know when to react. We're also going to need backup and infrastructure to run this on, and security. We're probably putting some sensitive data in our monitoring somewhere. We need to make sure only the right people see it. Oh, but what happens if the monitors go down? Who monitors the monitoring? So here's all the edge cases that we're going to run into. It's not just about taking some data and shoving it into a database. Are we able to build all of these things, and are we willing to? Well, there's also other options that we could buy. We should look at a few of those. One of them is a company called Track.js. If we run some numbers on what it will take us to build and buy, so if we take a developer, we think we can do it with one of our developers on an average employee salary of $100,000. We think we can build it out in about 4 weeks, but again, we probably need a day a month to tune it, make sure it's working, and patch the servers and that sort of stuff. Or we could pay a license cost of about $2,700. Well, with these rough numbers, again, from a straight numbers perspective, it doesn't pay off. It's going to cost us $7,600 to build this ourselves, probably, and another $3,200 every year in that 1 day a month. That 1 day a month really kills you. Whichever way we decide to go, we need to think about sustainability. We need to think about it on both sides. If we build it, can we maintain this? Are we willing to continue diverting time from our other Tyrannosaurus projects to update to the next version of Chrome? Or if we go with a vendor, how do we know that they're still going to be around when we need them? One thing to consider is their financial health, whether they're profitable, if they have outside investments, what their track record is. So looking at things like outside money is important, because often a company that takes a lot of outside money puts tremendous pressure on themselves to grow or die trying. And so most of them end up collapsing or get acquired by a larger company. So regardless, we need to think about our opportunity costs. What should we spend our time doing? Should we spend time building this monitoring software, or should we build bigger, scarier dinosaurs? I think we should build scarier dinosaurs. Buy monitoring, build scary dinosaurs. I think that should be our motto right there. And so right now, we're giving Track.js a try. We're seeing how it fits, but good early signs. And so here's how we came down on that build versus buy decision. So let me summarize what we've talked about. We learned a lot from the first park. And I think we're approaching this in a much better, a more healthy way, and we're going to build a more valuable park this next time. But some questions we need to continue asking ourselves. First, what's the impact of failure? Second, if we build this thing, is it valuable enough that we could sell it? Understanding what our bias is. Are we actively making a decision, or are we just going with what the culture is? What could we do with our time instead? Could we build a dinosaur instead of doing this? And regardless of which path, is it sustainable? I think these are the important questions for us to ask ourselves as we're building a piece of software, as we're creating a system, to make sure that we're spending our time and our effort in the best possible place. So, in the immortal words of Ian Malcolm, well, there it is. Thank you to Todd Gardner for inviting me here today to share these lessons. I hope you can go forward and not make the same mistakes that we did. I'm going to be available over here probably after to chat about dinosaurs, the next Jurassic Park, software, architecture, business, or JavaScript. If you'd like to come and chat with me, please come find me. Thank you very much.
Thank you very much, Todd. Thank you for your speech. And of course, we're having some small token of our gratitude. Thank you very much that you've been here with us. Thank you.
Thank you.
Round of applause again.